Hello everyone. So in today's lesson, we'll be looking at what is hypothesis testing. Hypothesis testing is an important tool to analyze data and make some inferences, which means that we analyze a particular given data that we have in order to make some conclusion or interpretation from that particular data. So, hypothesis testing is one of the tools which helps us to do so. That is, analyze the data and make some interpretations or inferences from it. So, all hypothesis testing follows a basic logic. So, basic logic is that an assumption or a claim is made, and if your data contradicts this particular assumption or claim, then you conclude that the claim or assumption made must be wrong. So let us take an example of an assumption or a claim and see how it contradicts assumption and when do we prove it is wrong. So let us assume that there is one particular route A to B which I take every day in order to reach the college. That is route 1. But on a particular day, since there was a roadblock in that particular route 1, I was not able to take that particular route. So the assumption here which I'm going to make is that I will have to take the route 1 every day in order to reach my college. But since we have assumed that there is a roadblock because of which I'm not able to take the route A to B, I will be taking an alternate route, that is A to B, which is route number 2. So because of this particular roadblock that I have, the assumption is contradictory. Data here contradicts the assumption that I have made, that I follow or I can follow route 1 A to B every day in order to reach the college. So here in this particular case, the data is contradicting my assumption. So I conclude that the claim or the assumption made is wrong. So there is an alternate route as well which I can take in order to reach the college. So this is a very simple example of the basic logic which goes into the hypothesis testing. So no matter whether you test a hypothesis testing for a single-tailed or a two-tailed test, you will follow the same basic logic. That is, make an assumption or claim and check whether the data that you have is contradicting the assumption or claim or not. If it is, then you conclude that the claim or the assumption made is wrong. So, for understanding this a little bit more, we are going to take the example of you are the production manager at a beverage manufacturer and you receive a bottling unit that has been recently readjusted so that it puts 200 milliliter of beverage in disposable plastic bottles. You need to test that indeed the bottling unit puts in 200 milliliter of beverage. For that, you fill out 10 bottles using the unit at different times so as to obtain a random sample and very carefully measure the amount of beverage inside each bottle. So there is a couple of important information which is given in the question in this particular slide. The first thing that we need to be aware of is that since the whole process has been automated in the bottling unit, the machines have been readjusted recently so that each of these disposable plastic bottles is filled with 200 milliliter of beverage. So here the most important point is this. That is, you need to test that indeed the bottling unit puts in 200 milliliter of beverage. So this is the assumption or the claim that we are going to make in this particular question. That is, the bottling unit puts in 200 milliliters of beverage in each of the disposable bottles. So this is the assumption that we are going to make. Now for this, since 200 milliliter of beverage in all the bottles of plastic bottles that has been manufactured by this particular beverage manufacturer, it is very impossible to see how much liquid goes in the thousands of bottles that it prepares every day. So for that, what we do is we're going to fill out 10 bottles using the unit at different times so as to obtain a random sample. So instead of taking the population for our study, we are going to take a random sample and measure the amount of beverage inside each of these 10 bottles. So these are the few important informations that we have in the question. So here, according to the question that we had, and as we discussed, the claimed population mean by the bottling unit is 200 ml. That is nothing but the amount of beverage that we are going to fill into the bottles. So that is the population mean. So before we go into the other details of the question, let's have a recap of the theorem that we have studied. That is the central limit theorem. So here we have a population, and since it is impossible to study the population, we take a small sample of size n from the population. So the population parameters denoted over here are the population mean mu and the population standard deviation sigma. And the sample parameters are the x bar is, that is the sample mean, is approximately equal to the population mean mu, comma, the population standard deviation by square root of n, which is the sample size. This can be applied to our question. So here the population is the all the possible number of bottles that the unit can fill. That is, the population mean is mu and population standard deviation is sigma. From here, from the population that we have, we are going to take a random sample of 10 bottles where the information now will change to sigma by square root of 10 since the sample size is 10 over here. So if the claim is correct, that is, each of the disposable bottles are filled with 200 milliliter of beverage, then we write the same sample mean as a normal distribution with parameters as 200 for population mean, comma, population standard deviation, which we do not know, by square root of 10, which is the sample size. Before we go ahead and solve the particular problem using hypothesis testing, this is one simple concept which helps you to understand when do we accept or when do we reject a particular claim or assumption. So let us assume a normal distribution curve, okay, and here the ones which are highlighted in red are my rejection region. The area in white is the acceptance region. So the acceptance region will be nothing but the population mean, which is the 200 ml of beverage which is being filled in each of these disposable bottles. So when the sample mean, now we have seen the formula for sample mean, which is 200 comma the population standard deviation by square root of 10. So when we calculate the sample mean, the value which we get, if it falls in the red region, that is the rejection region, this one and this one, then we will reject the assumption or the claim that the bottling unit fills in 200 ml of beverage in each of the disposable bottles. But at the same time, if this particular sample mean which we calculate falls in this white area, which is the acceptance region, then we accept the particular claim, which is nothing but that the bottling unit indeed fills in 200 ml of beverage in each of the disposable bottles. So this rejection region which we have, the red ones, are nothing but my alpha value. Since we have two tails on both the sides, we write it as alpha by 2. So the probability over here in these two red regions is nothing but alpha by 2 probability here and alpha by 2 probability here. Okay, so this is how, based on the sample mean value, we either accept or reject a particular claim depending upon where it lies. Does it lie in the rejection region or does it lie in the acceptance region? So again, going back to the central limit theorem where we have the population and the sample which is taken from the population, we know that we can use the z statistics only when the population standard deviation information is given to us. So the sample mean which we calculate is equivalent to the z statistics. So if the sample mean falls in the rejection region, then we will also say that the z statistic will fall in the rejection region. So when the population standard deviation is not given, we cannot make use of the z statistics. That is when we make use of the t statistics, where we make use of the sample standard deviation. So here again, the sample mean falling in the rejection region means that is the t statistic is falling in the rejection region. So based on the information given in this slide and the previous slide of when to accept and reject it, we will now go ahead and try to solve the given question that we have in hand. So for this, the hypothesis testing is a 4-step process. So the information which is given to us is the sample size, which is 10, the sample mean and the sample standard deviation we are going to assume. So sample mean here we are assuming it as 199 ml and the sample standard deviation as 0.8 ml. So the first step is to formulate the hypothesis. So in hypothesis, we have two hypotheses. One is the null hypothesis and the second one is the alternate hypothesis. These two hypotheses that we have, the null and the alternate hypothesis, will be framed on the population parameters. Okay, so here we know that the population mean is 200 ml. So therefore, the null hypothesis we're going to assume is H naught is mu is equal to 200. That is, the population mean is equal to 200. So for null hypothesis, always assume that it is equal to. And for the alternate hypothesis, we'll assume it as not equal to. So the null hypothesis here, that is the population mean, is equal to 200 ml. And the alternate hypothesis, that is denoted by HA, is the population mean is not equal to 200. So these are the two hypotheses that you will formulate. The second step is to calculate the t statistics. How do we calculate the t statistics? We know the formula that sample mean minus the population mean by the sample standard deviation by square root of the sample size. So we have all the information. Substitute the values in the formula. You will get the answer as minus 3.9528. Now we have got the t statistics value. This is the second step. The third step is to identify the cutoff values for the t statistics. So here alpha is the significance level, so which is typically assumed as 95% or 99%, which is nothing but 0.05 or 0.01. So here, how to calculate the point at which it cuts off, and we have the alpha by 2 probability. For this, we're going to use the t dot inv function. So the t cutoff value is calculated over here using the plus or minus modulus of t dot inv in brackets alpha by 2 comma n minus 1. So here the alpha is 0.05, which is we have assumed the 95% confidence interval, and n minus 1, that is 10 minus 1, which is 9. So the t cutoff value is plus or minus 2.622. So on this particular normal distribution, we see that we have minus 2.622 over here and plus 2.622 over this side. So at this particular point towards the left, we have the rejection region, and at this particular point towards the right, we have the rejection region. The last step is step 4, which is to check whether the t statistics that we have calculated in step 2 falls in the rejection region or not. So we know that this red region is nothing but my rejection region. This white area is nothing but my acceptance region. So this is the point, the cutoff value, that is minus 2.622, and here it is plus 2.622. After which we have the rejection regions. The t statistics value which we have calculated is minus 3.9528, which when we plot it on this particular normal distribution, it falls in this rejection region somewhere over here. So as we have already discussed that if the sample mean falls in the rejection region, then we will reject that particular claim. So here, since the sample mean, which is the t statistics value, is falling in the rejection region, then we are going to reject this particular claim. So we're going to reject the claim that the bottling unit does not fill 200 ml of beverage in each of the bottles. So this is the interpretation that we make for the example that we have. That is, the bottling unit doesn't fill 200 ml of beverage in the disposable plastic bottles, as the sample mean, which is the t statistic value, that is minus 3.9528, falls in the rejection region. So we are going to reject our null hypothesis and accept our alternate hypothesis, which says that the population mean is not equal to 200 ml. That is, the bottling unit doesn't fill 200 ml of beverage in each of the plastic bottles. So that's all for today. Thank you.